Hi, I'm Stephanie Ratcliffe, Executive Director of the Wild Center, and I'm here today with Chris Zanuck, and we're down in Chatham, New York, to learn more about the solar component of our pellet boiler project. This is Betsy Wyman. She's from Sundog Solar, and she's going to give us a little bit more information about our particular solar panels. Now, Betsy, we have about 200 solar panels on our bio building in Tupper Lake at our museum, but these are a little different. Can you just sort of explain that to me? What makes these different?
Sure. When most people think about solar, they think about solar photovoltaics. But these panels that we're talking about now are solar thermal panels. They capture the energy from the sun and convert that energy into heat to heat hot water for domestic hot water and building heating.
So really the word here that we should listen for is solar thermal.
Yes, solar thermal heating. It's different than photovoltaics.
So Betsy, tell me about your company. Tell me about Sundog Solar.
Well, Sundog Solar is a solar installation firm. So we install photovoltaics as well as solar thermal. We also do bio spray foam installation, and we perform home energy audits. But what we're doing up here is a solar thermal demonstration project where we're testing the efficiencies of different collectors because we want to know what works best in the Northeast to be able to advise our clients appropriately on what systems they should use.
There's many types of different solar panels, so let's go find out about the ones that we'll be using on our project.
At the Wild Center, we will be utilizing two different types of solar thermal collector technology. We'll be utilizing both evacuated tubes and flat plates. And Pete will explain in a bit more detail how each operates and the differences between the two. I'm holding a cutaway of a flat plate. Maybe you could start on that, Pete?
Certainly. Thanks, Chris. The nature of a flat plate is very, very simple. The sun comes in through the glass and is absorbed on a piece of thin copper. That thin copper is plated with a coating that traps the sunlight and turns it into heat. The heat travels to this little grid tube where there's liquid flowing through it. And that liquid heats up and then goes into a header here and then goes downstairs into the tank where that heat is stored for use by the facility. As you see, there's insulation built around this particular flat plate enclosure, and glass on the top completes this package. This whole thing helps hold the heat inside and then allow it to be transferred into the basement where it's used for heating hot water and heating the building.
And the evacuated tube, having a vacuum inside, I trust that there is some value to the vacuum. Could you touch on that?
The evacuated tube is a different way of capturing the BTUs that come from the sky. In the flat plate, we have a physical insulation. Here we have a vacuum. Like a thermos bottle, the heat inside is not allowed to get back outdoors because convection and conduction are eliminated by that vacuum layer. And by having this tube, we have a strong surface that can withstand a 35 millimeter hailstone. So its structural strength, the borosilicate glass, makes it possible so these are not fractured.
So the solar heated hot water that passes through this tube and this flat plate finds its way to a storage vessel somewhere in the building, coming out of this pipe and this pipe here.
That's correct. Actually, the fluid that we're talking about, the heat transfer fluid, is an antifreeze because at the Wild Center, unlike southern Florida, you have substantial freeze events and we don't want it to freeze. So the heat transfer fluid, or antifreeze, goes in the top, goes all the way to the bottom, and comes back up bearing the heat that the sun is giving this fin. And that heat transfer fluid goes down to what we call a heat exchanger inside the tank and gives off those BTUs to the water that will be used to heat the kitchen needs and the space heat needs for your building. Not only will there be tanks for the solar hot water, but we will also endeavor to use the existing storage in your pipes. You have very large pipes in the basement, and that will serve as a secondary storage site, not only for excess BTUs when we can store it there, but also for dumping heat in the summer if there's a time or a very sunny day when we have more heat then you can use during that noontime period. And then in the morning, you'll turn on your system, and that BTU that was stored there will heat your building.
Do you have a feel for how much of a benefit our facility would gain from the solar energy heated hot water?
In your case, what we're going to do is install a monitoring system like the monitoring system we have here. And the benefit of that will be to answer that question. How well will a system like this perform in the North Country where you have very challenging thermal conditions? It gets quite cold there, and various weather conditions where you have cloudy conditions as well as sunny conditions. So what our monitoring system is going to be able to do is provide information to you, Chris, so that you can make better decisions about how to operate the site, but also it'll be shared all across the state so other people contemplating systems like this can make a better decision about design and specification for the collection system.
Standing in front of a solar thermal demonstration unit. Luke, could you touch on this and explain what it's all about?
Absolutely, Chris. This is the Sundog rover, and what this is a working, functional model of a solar thermal system, such as the one we have functioning right here. Now, this has essentially everything a teacher needs to teach people about solar thermal energy. You notice up here in the centerpiece is the AET flat plate collector. This is the same collector that we have up on the roof, and the same one that will be installed at the Wild Center. Now, this collector is supplied with fluid, this heat transfer fluid, by a pump down here in the basement. And that takes your heat transfer fluid, which in this case is non-toxic propylene glycol, and pumps that up through the collector. Now, that fluid moves through the collector and picks up heat energy from the sun. And it exits here at the top of the collector, warmer than it is than it comes in here. Now, it takes that heat, this heated heat transfer fluid, and brings it down into a hot water tank in the basement. Now, that hot heat transfer fluid spins around this heat exchanger, which is a coil that helps give off the heat it collected into the water that you'll use for your kitchen and for your heating. And once that gives off the heat, it's pumped back up to the collector on the roof. And as this goes on over the day, it sends more and more heat down into your solar tank.
So this isn't considered a passive system. This is an active system, correct?
Correct. This is considered an active system because it has a pump. It's also considered a closed-loop system because the heat transfer fluid does not interact with the water in your tank.
So this tank here serves the purpose as both a heat exchanger and a storage vessel?
Yes. As you can see, the heat exchanger is actually this red copper coil which we inserted in the tank. And we've also showed how you can attach a solar tank into an existing hot water heater that a person might have in their basements.
We've seen a lot of great things here today at Sundog Solar, and I'm here with the president, Jody Rail, and your team is great. I'm so excited to have you come up and install your segments of our project. But before I go, I got to know what this is. Tell me about this.
This is the solar-powered GEM car. It's a solar-powered vehicle, and it provides a lot of music.
So you can have a concert powered by the sun?
In the field, in the street, anywhere.
All right, we're going to have a project at the Wild Center just so you can bring this up.
Great.
We've seen a lot of interesting things here today, the solar dimension of the project, the pellet boiler itself. Both of those things are going to really help us lessen our dependence on fossil fuels. So at the next segment, we'll be showing you the installation of the boiler, and after that, we'll be able to fire it up.